Okay, I'm looking forward to disappointing all of you. My name is Sunil Pai. My friends call me Pai, so I guess all of you can too. I've done a bunch of web work. Let's get straight to it. Unfortunately, I want to change the topic at this very last minute. So instead of talking about JavaScript and stuff, I want to discuss How to Train Your Dragon is the best movie ever, and how to apply it to stuff like CSS and JavaScript. Of course, we'll talk about thought leaders, and they will quote. Nah, I'm just joking. Let's talk about this. Uh, La Nouvelle Vague. I hope I'm pronouncing that right. Patrick made sure that I did. So the new wave is a phrase that's been used across, like for the past 50, 60 years in many forms of entertainment, for film and music, and in many countries, the US, UK, Africa, India, French New Wave of cinema, which is where, of course, the phrase comes from. And while there doesn't seem to be any real connection between them per se, there are some attributes that we can see are the same. Like one is the rejection of authority and the idea of best practices. How to make a movie? What does a song sound like? What should a book read like? So you reject those ideas. Secondly, uh, while it might seem like it's mostly experimental and a bunch of kids just trying out stuff for fun, they usually have very high production value, so that you can't really complain that not a lot of thought has gone into it. So what does that look like for technology? What do I mean when I say the new wave of frameworks for front-end development? Well, let's just look at the facts right now. What's really happening in the web? Uh, the web is now accessible to billions of people. We're finally at a place where we use the B word. And what it also means is that it's accessible across a whole number of devices, from incredibly strong workstations in first world countries to $20, $30 cell phones in third world countries. Uh, in fact, I come from an India where I have to create websites for all this entire range. Well, in India, you may have to make sure that your website works across this entire range. Otherwise, it's an accessibility issue. People without a strong enough phone or even bandwidth will not be able to access your site. But we have gotten to this place where we do send too much code to browsers. It is not uncommon now to be sending MBs worth of JavaScript and CSS and, well, does anyone send an MB of HTML to the browser? I don't know. We could try, just to make the trifecta. But we do. Even your friendly social network site, they send MBs of sites. Of course, they do it efficiently and they try to do it well, but it also means that there is a Facebook Lite in countries like India, because it doesn't really work across all devices. Secondly, over the last 10 years, we seem to have shoved a lot of things into the browser, not just in terms of JavaScript, but in terms of capabilities. And it isn't easy to program by hand efficiently or even to get into. Beginners are always overwhelmed by the scope and breadth of all the things they have to do to make sure their website is accessible to a lot of people. We can do better than this, and the community has been showing us the way. I see it in compiled to JavaScript languages, because JavaScript is now mostly a compile target, really. I don't think any of you really write JavaScript by hand anymore, especially if you're using JSX, right? The CSS and JavaScript community, even though it seems like we argue amongst each other, we are actually like cooperating, and there's a whole lot of ideas proliferating around it. There are route-aware bundlers. This not so much in the React world, though we'll talk about a couple of examples there. But stuff like Polymer and Ember has been showing us the way, where the routes are considered first-class entities in their stack. And of course, vertical stacks, which include a whole bunch of other things. They might be made particularly by your company to include stuff like design assets and stuff, or something like an Angular, which includes a router and so on and so forth. So what exactly then is the new wave of frameworks? So when React came out, this was one React came out and everybody thought that it would be a competitor to something like an Angular, right? And Angular is incredibly popular, used by a lot of people. And people thought that this would be a competitor, but except it turned out that React only was the V in MVC. And you had to bring your own router and other pieces. And this essentially led to what we consider JavaScript fatigue, where you're not really sure what pieces you want to put together to get the things you want. And if you want to switch them out, then you have to rewrite your entire stack. So instead, the new wave of frameworks that are coming, that have been showing up over the last couple of years, well, they aren't really frameworks at all. Again, we will go into examples of this, but I want to impress upon you the fact that it isn't even code that's being sent to the browser. It's stuff that's happening way before that. One big inspiration for this talk is is a framework called svelte.js. I hope if you haven't seen this, you should check it out. It's by a very smart man named Rich Harris. He wrote a blog post about this in November last year. Of course, nothing else interesting happened in November last year. But yeah, he wrote this entire blog post where he was talking about, well, maybe we can have the developer experience of writing single-page applications, because that's what we're comfortable with. Writing JavaScript, describing our entire stack. And then he runs it through a magic bundler, and it pulls out the bits that don't have to be sent to the browser and can convert things to other, well, more efficient assets, HTML templates, plain CSS files. So that's cool. So what then are the characteristics of these new frameworks that have been coming out? Well, the whole deal is that as a front-end community, we are now getting into this idea of compilers as first-class tooling for ourselves. You remember 10, 15 years ago, JavaScript being called a toy language? We had to write it by hand, and we didn't really have the tooling to do any fun stuff with it. But it did mean that anything complicated would bump up into human limits, right? And it would be strange because we have computers to do all these things. So compilers now have come into the fore where we get to seize the means of production of these bundles and this code, which is awesome. It means that things that were hard for human beings to do, we can now make compilers to it. And by compiler, I mean anything that comes before you actually send bundle to the browser. So this would be a Webpack, it would be a Babel, it would be a Flow, it would be a little Babel plugin you wrote just for your use case for CSS and JavaScript, which is not controversial at all. Again, to repeat myself, these compilers then compile away what would have required in runtime support, stuff like type checks and stuff, and possibly infinite dev time, and they give it to you in your development experience, but not necessarily in the browser. Also, one characteristic of these compilers is that you don't really have to write your entire stack in it. Something like Flow you can introduce gradually into your code, just for some files. This is huge for adoption. If you cannot do this, and this is a characteristic of React as well, right? If you cannot do this, then you're kind of dead on arrival. So gradually being able to annotate your code and add these things to your code is another characteristic of this. Like I mentioned, routes are, in the examples that I talk about, these bundlers are very aware of routes as first-class entities. And pardon the language, but these compilers now give us a way to introduce new technology into our stacks without us losing our shit. I've been thinking of a better phrase for this, but no, losing my shit is fairly accurate. Anyway, so let's go into examples, right? One of my favorites is a framework called Gatsby.js for making static websites. It's by Kyle Matthews. He might be in the crowd somewhere. Hi, Kyle. It's really cool. And blazing fast static websites with React is the tagline for the framework. It lets you write posts and web pages in Markdown or React or really anything you want if you're advanced enough to add this functionality to Gatsby. Excuse me. So yeah, it gives you the development experience of just needing to do the work that you need to do, your business logic stuff, and it takes care of all the fancy stuff behind it. It's quite a beast behind it. It compiles it down to optimized code. It figures out how you can preload scripts while you're loading the page. Maybe he'll get to a place where it can stream it. I'd like to make that feature request to him. But Gatsby.js is one of my favorite examples for this new wave of frameworks. The other one I want to talk about is Next.js. Next.js is awesome. Guillermo, who actually made him and his company, who made this, he likes to think of it as an alternative to PHP, because you can just make folders of files, and those correspond to routes, which, you know what, that's kind of nice. We should have stolen that from PHP a long time ago. So Next.js is awesome. These are things that you should all check out. Of course, Relay is, I'm sure a bunch of you use Relay, which uses GraphQL, where you can declare your data requirements, and then a compiler looks at it, pulls out all those queries, makes the bundle even smaller, and sets up server-side endpoints. It's pretty cool. So Relay, Next, and Gatsby really are typical of what I'm talking about, this new wave of frameworks. None of this really add many runtime concerns into your code, but they do give you a framework of way to build your website to be fast, very important, and to be simple. One new player, which isn't really a web development framework that's come out, is Prepack. Prepack is awesome. It lets you run your JavaScript and then figures out the state of the VM, and you can send that state as more JavaScript to your browser. This might not necessarily mean less JavaScript to your browser, but it does usually mean faster JavaScript. Sometimes parse time is faster. Obligatory exhibit photo. Cool. So now let's talk about my experiment. So usually people come to conferences like this with 1,000 people. Oh, I just realized there are that many people. With something finished to market it. I haven't really finished this yet. This is experimental. It's going to take probably months to get right, but I do want to share the ideas that I've been working with. I feel like some of them are unique enough that this is a good place to share them. So, characteristics of Wracked. There's 0 new APIs to learn, really. Like, you should be able to use your common stack. The examples that I'll show you use React Router, but it should be easy to use with anything else. It's annotation driven. Like I said, you should be able to gradually add it to your stack. There's no reason to just rewrite your whole stack with Wracked. You can even do it for like a small page or just a component. The ideas present in Wracked could be applied to any component stack. So not just React, really. I want this to be available in Vue and in Ember, and I mean, Polymer already has a story. They can do what they want. But yeah, I want this to be used by everybody. Some of the ideas are nice enough. And they are fast defaults. You shouldn't be looking for performance as a feature later. It shouldn't be something that you work towards. It should be something that comes naturally. The phrase pit of success comes to mind, where it is fast by default, and actually you have to mess up your code to make it slow. But nothing in the framework itself encourages you to write stuff that's fast. So what does it look like? So it takes the React Router API, and it says instead of passing a module that you import from, well, let's say you're making a user route, and instead of using a module that you import from there, you just pass it the path to the module. Some eyes might be raised here, because if you know the specifics of how bundling works, you'll know that Webpack and stuff won't be able to pick this up. You need an import statement somewhere. No need to worry about that, because Rack takes care of that for you. In fact, it takes this little piece of code and generates this junk. You don't even have to read it. But all this junk is required because we want stuff like server-side rendering support, but also deferred support, and any pattern that you want to, which I'll show you examples of in a bit. But there is no way that you can expect a human being to write this by hand for every module that you want to import. It's cool, and it's scary, but it works. Secondly, how do you do data fetching in Wracked? Well, you know how you collocate queries in Relay with your component? Well, what if you could collocate real server-side code with your component? I'm literally requiring Mongo's driver here and making a fetch and passing it on. Now you know that you don't really want to send all of Mongo to your browser. But what Wracked really does is it takes that entire code, sets up an HTTP endpoint, and replaces it with a single identifier, just like Relay. That's kind of cool. That means that you're actually co-locating server-side code with your client-side code. There are some heads that are question marking this, but trust me, it kind of works. It's nice. And it means less code to your browser, less code than even you're writing. All your requirements get stripped out. There are a couple of edge cases, but over the next couple of months, I'll fix that. And that's it. There are no other new ideas in Wracked. Okay? And you'll be like, well, if that's all that it does, then what can you really do with it? So to answer that question, let's just talk about what React really taught us, right? React taught us that our views are functions of data. And that's nice. This is the E is equal to MC square moment for UI development, really, I think. It became a first-class concept that all of us could talk about. Further, it meant that those functions are components, and then we know exactly what to write. If we have data and we have components that wrap them, we can create views. Nice and simple. Well, then couldn't we then say that an application really is a function of the code that you write, and then that function actually is the bundler? Right? We can look at that. We could say that if you pass your code to a bundler, it generates an app. So the bundler is where you actually, but the bundler is the layer then where all this fancy stuff can exist for compilation or flow and type checks and so on and so forth. In fact, what Wracked does is it takes your code and it splits it out into a whole bunch of things. It can figure out mappings between routes and modules. You can figure out the assets that you're using. A couple of these are features I haven't even implemented yet, but you guys will believe anything. It pulls out the CSS and ponies and views and all that jazz. But the idea being that you should be able to statically analyze all your code and separate these concerns, the things that we want our computer to do for us and not do by hand. the nicest bit of being able to do this is that now, without actually rendering your component, given any URL, /user/123, I can immediately tell all the resources that are required by the page, right? Because I've been able to strip all of these out. Otherwise, there's no need to render it down and then look through the tree and use Helmet to pull these things up and all that does. No, there's a simple function that inputs takes in a route map, which we have already extracted and inserted into our bundle, and even we can send it to the front end. And we can do a whole bunch of cool tricks. So for example, before we even render the component, we can send link preloads to the front end. Like we can just chunk. Sasha will be very happy that I've actually implemented this. I want him to work on this as well. You listen to his server-side rendering talk, it's pretty cool. But to steal a little bit of his thunder, you should be able to implement these things fairly trivially now that you have a route map of URL to assets. What else do we get from something like Wracked? Well, we get an automatic app shell. App shell is a phrase that's come from the PWA world, if I understand correctly. It's fairly unoriginal as a name, frankly. But it does mean that anything that's upwards of any of your routes becomes the app shell automatically, and that will be the first bit of code that you send to the front end, whether you're using server-side rendering or not. You get stuff like tree shaking, chunking, loading assets, again, fairly efficiently. You avoid fetch waterfalls. This is a problem with dynamically declaring your data requirements inside components or with routes, right? But because we have been able to statically analyze it, we can avoid fetch waterfalls, which means that you have to wait for some piece of code, some data to load before you can load the next bit of code. You don't have to really do it manually. The computer takes care of it for you. Most importantly, because the API surface is that tiny, just those two things, it means that you are free to extend it as you please. The rest of your stack stays the same. Nothing really changes. You don't even have to use React router. You can write a little modification of React that does it with whatever your routing system is, even if it's a static route config, whatever. You don't even have to use React. Just use the ideas, and you'll get all these things automatically for yourself. So what are the cool new things actually that Wracked then unlocks for us? So as I explained to you, server-side rendering is fairly important to me, so it'll be a common theme over the next over the next few slides. So if you use Wracked by default, it is your standard single-page application workflow. Nothing really changes. You get stuff like code splitting for free. You can do streaming if you use the serving infrastructure. Otherwise, you just use an HTML page with tags. Nothing different. It would look like this, right? You would enter example.com, wait for a bit, the script tag loads, and it renders the page. Fair? This is fairly common. Cool. The next pattern, of course, is server-side rendering. Maybe you want to server-side render your pages before actually sending JavaScript in front. This is, again, a common pattern, but it gets super complicated because of the asynchronous nature of the first render of React and the fact that code splits return promises. I've heard, like, this was easily the hardest part to get right, and it resulted in that jumble of code that you saw earlier, but it's done and it works. But yeah, so then what does that look like? Well, you'll end up loading a page. You assume that you render just the server-side content, load the script, at which point it becomes interactive. OK, cool. So these two things are what we can fairly already do. So we've not really removed any functionality yet. Now the fun stuff starts, right? Well, maybe there are some parts of your page that you don't really want to render on the server. Maybe you just want to do it lazily on the front end. Maybe it's something below the fold that you want to load after the user scrolls to it. Well, it should be as simple as adding one single attribute to your route, just say defer, and it should work. And again, as an example, you load the first part of your page, make it interactive, at which point it loads the other bundle and gets the rest in. Nice, just by adding one single attribute to your routes. There's another pattern, and this is also fairly exciting to me. Web components, actually web component proponents keep talking about one advantage of web components, which is that if you say web components 3 times, does the Google team show up here? No. So one of the advantages of using web components really is that you can start up code for leaf nodes, the lower parts of your page, before you even load the rest of the page. Of course, that stack, and I suppose Polymer actually tries to solve it. It doesn't help figuring out how to actually synchronize these things. Most A, because it's an imperative API, and B, well, they just haven't done it really well yet. But we want to be able to do this. A good example of where this is useful is carousels on web pages. Have you noticed when people start clicking on carousel buttons before the script tag even loads and they think that it's broken? They think your website is broken and they complain about it, but that's mostly because they have slow bandwidth. Wouldn't it be nice if you could just load the JavaScript for one part of your page and then the rest of the page later? Like you wrote the rest of the whole bundle, including the app shell later. Well, with Wracked, it's as simple as marking one bit as a leaf. What that then does is it'll load some server-side code. It'll load, so it'll server-side render a whole bunch of code. It'll then load just the code for your carousel, not even your app shell, nothing outside there, and it'll run it inside there. At which point, after which the rest of the bundle loads, and the page becomes interactive. Most importantly, it picks up the state that was already being used in the carousel. So like it maintains what position you are at. This is huge news like for a lot of people, because it means that you don't even really need to, once you, let's say you load this, let's say you're at this point, you can choose not to load the rest of the bundle. For e-commerce pages, like the rest of the page might not even be interactive. They might just be images or stuff. If you're smart enough, you might not even need to load React. That's kind of neat. But yeah, so leaf nodes as a new pattern that Wracked can unlock for your pages. And finally, and this one is a little complicated to explain, but I'll try. There are some times when you want to server-side render some code, but not include its code in the bundle and have it loaded later. A great example of this is D3. If you use D3 heavily, the output actually is very light. They're just SVG tags. But the library is fairly heavy if you use something like maps and projections and stuff. And then you have a problem, right? Like, you want to server-side render it because it's just that much. But then if you include it in your code, your page is going to load slower. But then if you try to import it asynchronously via code splitting, well, you're hosed again, because then it'll wash out the HTML that was already generated at the server side. Well, with Wracked, this isn't a problem. You pass it one more attribute called preserve. I'm open to better names for all of these. It's what I came up with. You just pass it preserve, and it should just work. So it would look something like this. So it would make the rest of the page interactive, wait for the rest of the, and it'll preserve the server-side render code until the actual bundle comes in, and make it interactive when it actually loads. Might not seem so impressive, but again, if you think about the D3 use case, it makes sense. You don't have to wash away your HTML before the JavaScript actually arrives. What about CSS? These are slides I added because clearly it's a very topical thing. There are a whole bunch of CSS in JavaScript libraries. I made one. I didn't even expect it to get famous. I was just messing around with a couple of APIs, but I like it, so you should use it. It's called Glamour, 3.1/Glamour, please. Give me stars. However, there are problems with Glamour, and it goes against the grain of what I spoke about in the beginning. It's a pure runtime solution. It's a pure runtime solution because it papers over some of the inadequacies of CSS, mostly when it comes to composition models, but it does let you write like full CSS with no drawbacks. However, I've been thinking about it by the context of this nouvelle idea, and I came up with another library that I called Glam. Clearly, I'm no good at naming stuff. But Glam is a CSS in JavaScript library that takes your code and can statically extract the static bits of CSS, and it uses CSS variables for the dynamic bits, just as the standards folks wanted, and it has amazing performance. It's like 1.5 KB of just little code that you want to send to the front end, but you could even get away with that. You don't even need that if you're not really using CSS variables or any dynamic CSS. The entire bundle can disappear if you don't use that. That's nice. So what does it look like? Well, you write code like this. I don't know if you can see it, but it's just a fairly, it uses tagged literals to write CSS inline in your JavaScript. Does a couple of interpolation for variables, and you can use it in a React component. So it takes that and it splits it out into files. The JavaScript file, the CSS is actually replaced by a class name and placeholders for the variables that are coming in. That's a CSS file that's generated statically, so you can load it with like a CSS loader or whatever. And it puts in dynamic variables when it uses it. This is awesome. This is exactly what CSS variables were meant for, and it's fast, and it satisfies a whole bunch of thought-leading principles. But CSS variables, there is a slight problem. If you look at caniuse.com, it looks like there's fairly good support. Ignore the IE column always, I suppose. But it looks mostly green. And you might think, well, this is something that we could use in production right now. Except it turns out the truth is not really standard across the world. If you look at it in terms of from India and you include mobile browsers, it looks more like this. which means that more than half, well, close to half of everyone will not be able to access your website, and the CSS won't work if you want to do dynamic stuff. However, Wracked and Glam really controls the means of compilation, which means that we can send a browser-specific build just for those browsers, which is a pure runtime version, which is an acceptable trade-off, I think, for browsers that don't support it. We control the generation of the selectors and the actual CSS. And if you had attended my CSS and JS workshop yesterday, you would have seen how cool it is. But it is pretty cool, so you can try it out. But yeah, we can now do this. This, I think, would be the first proper polyfill of sorts for CSS variables, because I haven't seen it elsewhere. Only by the fact that we control the means of compilation of the entire stack. It's neat. So, in summary, you want to have a look at your code and wonder why, you want to ask yourself what code you're actually sending to your users, whether it really makes sense to them. I understand that developer experience is, well, it's really important because it's how you actually ship stuff to production and it's how you avoid bugs. And there are people who think developer experience leads to bad user experience, and we want to be able to destroy that myth today. We want to say that, no, it does not mean that at all. It means we can still get the awesome developer experience that the React ecosystem gives us, but we can still send efficient bundles and code and assets to users without them having to run code that we don't need to. That saves a whole bunch of CPU cycles. You should be able to co-locate your concerns like CSS directly in your files. And tools should be able to then separate those technologies into separate files and to get all the goodness of old school web development. And finally, these things will look strange and new ideas usually will. I think that these are good ideas. Some of you might not. But then I ask you to find your own new ideas that go against the grain. Best practices really have shown up because they were a good idea at the time, but like someone said, we keep developing for the web like we're riding a horse-drawn carriage, except that the horse has been replaced by a V8 engine, literally a V8 engine, years ago. So we want to re-examine all these best practices and see what we can do better, not just for developers, but also for users. I want to thank 3 libraries that I was using for this. Webpack 2 is awesome. So thanks to Sean and gang for helping me out. React, of course, is why we're all here. And React Router and Ryan and Michael and all those guys, they've been super helpful in doing this, in making this come together. I hope to make this library production ready in the next couple of months, hopefully. But I also encourage you to come up with your own ideas along these lines and introduce it into your stack. Thank you. That should do it.